Hello everybody and welcome to another enVision's Algebra 2 video. We're going to be looking at topic 4, lesson 3. I'm going to start with the concept of a rational expression and then we're going to go into example 1. So a rational expression is the quotient of two polynomials. The domain is all real numbers except for those in which the denominator is equal to 0. All right, so here's a key thing. We talked about domain before. In rational functions, your domain is going to be all real numbers except for that 1, 2, or 3 different numbers that will make my denominator equal to 0 and make my rational function undefined. Because if you remember, if a denominator is equal to 0, then it is an undefined point. All right, so negative x squared divided by x squared minus 9 is an example of a rational expression. Since the denominator cannot be equal to 0, we're going to take that denominator and we're going to say cannot be equal to 0. And then we're going to find the values that will make that equal to 0, which is 3 and negative 3 in our case. So the domain of negative x squared divided by x squared minus 9 is all real numbers except for 3 and negative 3. And again, we saw that these are also our vertical asymptotes for our function from before. And you can test this out by getting closer and closer, making x values closer and closer to 3 and negative 3 and see what value they converge to. All right, let's go to example 1. So write an expression that is equivalent to this polynomial over this polynomial or this rational function. All right, so let's see this. Start at the top. I've added some lines in before because my division lines are never the greatest. So what I'm going to do first is I'm going to factor this. These both are in standard form, and I'm just going to factor to see if there's any way that I could reduce this, just like you would reduce two different numbers, like 10 fourths into 5 halves. We're going to see if we could reduce this by factoring out values that are the same from the numerator and the denominator. All right, so the first thing I'm going to do is look for the greatest common factor, which is going to be an x in both cases. So we're left with x squared minus 5x minus 24 divided by x squared plus x minus 72. Okay, I'm going to factor this a little bit more. We want this to be linear factors, which means x to the power of 1. So I'm going to factor this a little bit more. I'm going to take x and x here. Let's see, two numbers that multiply to give me negative 24, but add to get me 5 is going to be x and 3, x and 8. All right, so this is a negative, which means one of my values is going to be negative. I'm going to go to the b coefficient to figure that one out. So b coefficient is also negative, which means the bigger number is going to be negative. Denominator, we're going to go x and 9, x and 8. Again, for the sign, because this is a negative, I'm going to go to the b value to figure out which one of my factors has a negative. And this is a positive x, which means my bigger number is going to be positive. Okay, I'm going to take a moment here to define the domain. Before I start canceling anything out, I'm going to define my domain. Because if I start canceling everything out, I might lose two pieces of my domain. So my domain of my function is when these factors are equal to 0. So it's just like that zero product property. We're finding it to the denominator, and this is when they cannot equal 0. So in our case, my domain is x cannot equal 0, it cannot equal negative 9, and it cannot equal 8. Okay, so now that we've found the domain, and you need to find the domain before you start canceling factors out, we now can cancel factors out. So that cancels that out, that cancels that out. An equivalent form is x plus 3 divided by x plus 9 equals that x cubed minus 5x squared minus 24x divided by x cubed plus x squared minus 72x with a domain of x cannot equal 0, -9 and 8. All right, so let's go look at the try it. Oh, let's look at the communicate precisely. A statement of equivalence between two expressions is an identity. The identity is only valid where both expressions are defined. All right, so if we look at the solution here, again, here they're kind of giving you that idea of simplification of looking at the factors and what's equivalent. So 3/4 is equivalent to 12/16. Here they take the factors. Again, step 2 is always finding the domain of the rational expression. Before you cancel anything out, find the domain. And then step 3 is basically x over x is 1, x minus 8 over x minus 8 is a 1. So when we say canceling out, what we really mean is that you're making it 1 times the values, which we're left with x plus 3 over x plus 9. And then with a domain of -9, 0, and 8. All right, so it's your turn to try. Here's a function. They gave you x to the 6th. Think about what the smallest value you could pull out of here, especially x to the 3. That should actually pull you down to an x squared. And then I think a 2 you could do from the denominator and a 3 from the numerator. So look at your greatest common factors first before you start finding the other factors. All right, guys, so I hope you guys have a fantastic day, and I will catch you in the next video.